Hi, in this lesson, we'll look at accessor methods. In a previous lesson, we learned that instance variables are generally labeled with the keyword private to prevent users from having direct access to changing the state of an object. Rather than allow users to manipulate data directly, we use accessor and mutator methods to control what aspects of an object that users can alter. These are used in place of directly accessing the object's variables, so as to simplify how users interact with objects. In this lesson, we will dive deeper into accessor methods to learn more about how they can be used in our programs. Since accessor methods are often providing information about an object's instance variables, they generally have a return value to return the object state to the user. As we learned previously, the return keyword returns a single value back to the program that it was called from. In this case, the value of width is being returned whenever the method getWidth is called in a program. It's important to remember that the data type being returned to the program matches the return type that is specified in the method signature. Since this method's return type is an int, the value that is being returned from the method must also be an int type. When a primitive value is returned to a program, the value is a copy of the initial primitive value. Here, the int widthTester is being assigned the value of rect.getWidth. Because the rectangle's width has been assigned the value 10, the value 10 is returned from getWidth and assigned to the variable widthTester. When we print the values widthTester and rect.getWidth, they return the exact same value. This is to be expected, as widthTester has been given the value of rect.getWidth. Let's say we want to change the value of widthTester to 17. We can reassign the widthTester to be equal to that value. When we print the value of widthTester and rect.getWidth again, we can see that the initial value of rect is unchanged, but the value of widthTester has been changed to reflect the change that was made in the program. Because the return value is a copy of the initial value, the original is unaffected. This is referred to as return by value. This process, however, is not the same for when we return objects back to a program. If the value is an object, the existing reference is returned to the program, not a new copy of the object. Let's return to our superhero class and add an accessor method, getPower, so that the user can get the power of an individual superhero. Because power is an object, the return type in this method must be a power object, and the item being returned is a power object as well. If we create a new superhero, Flash, with the power speed, we can now assign the power using the getPower method. In this case, we will assign flash.getPower to the variable test. When we print the value of flash.getPower and test, the values should be the same, as the object data was just assigned to test from flash.getPower. However, if we change the value of strength in test, the value of strength in Flash's superpower power will also change. When both values are printed again, we can see that both power objects have changed as a result of the change to test. This is because both the Flash's superpower and test's superpower reference the same speed object. Remember that when a variable is assigned the value of an object, it points to the existing object and does not create a new one. Returning an object will return a reference to that existing object and point to it whenever changes are made to either reference. A specific type of accessor method that is useful when developing classes is the ToString method. The TwoString method provides information about an object's instance data. In this case, the TwoString is returning the name of the superhero and the power that the superhero has. TwoStrings always return a string type to the existing program. When a TwoString method is created, it overrides any existing print methods and becomes the default method called when system.out.print or system.out.println are called in a program. When either is called, the program will look to find a TwoString method for the object. When the TwoString method is found, it will return the string associated with the TwoString method anytime a print statement is called. Now that we've learned a bit more about accessor methods, let's get some practice. Imagine that the superhero class also needed to include a secret identity class. A superhero's identity is comprised of their real name, their occupation, and their home planet. Here is a constructor for the secret identity class. Using the class we just built, let's create accessor methods to gain access to the different instance variables. Can you figure out all the accessor methods we need for this class? Pause the video while you figure it out. The 4 that we need to create are getRealName, getOccupation, getHomePlanet, and a TwoString method to get information about all the instance data. Let's create these methods now. Can you figure out how to program these before we move on? Here is an implementation of those 4 methods. As you can see, they all have return values and the string return type. Did you get them all right? Now that we've learned about accessor methods, let's get some practice using them in the CodeHS editor.